let's play algebra and solve some equations. We will remember this from our GCSE, but it can be worth reiterating if it's been a while since you've been playing with algebra. The key to solving any equation is this. You perform the same operation to both sides. This is an equation. The two sides are equal. So if you want them to remain equal, whatever you do to one, you do to the other. And we want to know what x is. So our goal is to get x all by itself. So we've got a plus 1. How do I get rid of a plus 1? I subtract 1 to both sides. So that will tell me that 2x is equal to 8. Now intuitively we know what that means, but if 2x is 8, how do I get from 2 times x to 1x? I divide by 2, which will tell me that x is 4. Same thing, both sides. Fractions, no worry, mate. We will deal with them. Now, what order do we go in? Now, we remember our BID or BODMAS, depending on where you're from. All right. Now, we want to work backwards. All right. So the first thing I undo is my subtraction. So I'm going to add 3 to both sides. The reason we work backwards is that we are basically coming at this from the other end. We know what the final answer is 5. So we are working backwards. How do I undo? That is b divided by 2. That's all a fraction means. So how do I undo a divide by 2? I multiply by 2. So that tells me b equals 16. Now brackets, no worries, completed it, mate. All right. So first thing we're going to do is deal with our multiplication, the 2 times 2. So how do we undo a times 2? We divide by 2. So it tells me that a take away 11 is 7. Then I can deal with the addition. Now the reason why I didn't deal with the addition first is because it's actually inside the bracket. All right. So this here is my bracket. So it's the last thing I'm going to deal with. So now that's all I've got left. We can get that a is 18. Now there is another way to do this sort of question if you prefer. We could start by multiplying out the bracket. If the bracket confuses you, just multiply it out. That is 2a take away 22 is 14. The downside is we are now working with bigger numbers. We add 22 to both sides to get 2a is 36. We then divide both sides by 2 to get a is equal to 18. And these two methods agree. Now, you will get problems where you are given a formula and you are expected to find the missing bit given some values. So here, p is 12q minus 5. Now, if I know that q is 4, find p. Well, if I know that q is 4, the equation becomes p is 12 times 4 minus 5, which is nice and easy. That is 48 minus 5, which is 43. What if instead, I told you that p was 43. Well, we could have gone the other way around. So we plug in p is 43, is 12q take away 5. Now we're going to solve that for q. Now we don't need q on the left-hand side. The thing I'm looking for can be on either side. So we're going to add 5 to both sides. That is 48 is 12q. And then divide both sides by 12, which will give me q equals 4. Same question from the different points of view. Now you could get a formula with lots of different variables in it. Now, if I know that a is 11, b is 3, all we do is we plug those in. That is 2 times 11 plus 3 times 3 is equal to c. That is 22 plus 9 is c, which tells me that c is 31. Or I could tell you a is 6, c is 42, and we just replace those letters with those numbers. So 2 times a plus 3b is equal to 42. 12 plus 3b is 42, because I know 2 times 6, because I is well smart. Take away 12 from both sides, and that will give me 3b is equal to 30. Divide both sides by 3 to get b is 10. Now, we could have equations to solve with x on both sides. Really, it's up here. We are going to collect the like terms, then we're going to solve. So we want to collect the x's on one side and the numbers on another. So looking at this, I want to keep my x's nice and positive. You could not worry about that. So I'm going to subtract 4x from both sides. I'm going to add 23 to both sides. All the way through this, whatever I do to one side, I do to the other. Divide by 6, which tells me that x is 3. Right, now brackets. Let's say I don't want to deal with these brackets on both sides. What you could do instead of expanding both sides is, in fact, I could divide both sides by 3. Because that will just give me t minus 2 is 4 times t minus 5. Now I'm afraid I'm out of funky stuff, so I'm just going to have to expand this out. I'm going to take away t from both sides, so I've only got t's on one side. I'm going to add 20 to both sides. And then I'm going to divide both sides by 3. Awesome. Now, in a wordy problem, and you will get more practice on this, the key thing is take the unknown you're looking for and replace it with a letter. I go with x. We're then going to form the equation. Like the information in the question will give you an equation, and we solve it. So we have 2 test kits per patient and 3 kits left over after testing. They started with 15 kits. How many patients were tested? Right. So they started. So this is what we're looking for, the number of patients. Okay. So 2 test kits per patient. How many test kits is that? Well, that is 2 times x. If there are x patients, 2 test kits per patient. So we started with 15 kits. We used up 2x kits per patient, and we were left with 3. We solved this. Now, we've got a few different ways we can do this. Let's just keep the x's on the left-hand side, just to show you what could happen. We could move them over to the right-hand side. So we're going to take away 15 from both sides, is minus 12. Be careful of that negative sign. It doesn't disappear. Why would it? That's just not fair on the negative sign. And we're going to divide by negative 2. And because, again, we are well smart and great mathematicians, as I don't forget my minus sign, a negative 12 divided by negative 2, a negative divided by a negative is a positive. So how many patients? 6 patients. Et voilà!